Having looked at the uses of deep learning and the principles behind it in the first two videos in this series, it's now time to take a look at what makes deep learning work. It should be clear by now that a convolutional neural network, or CNN, involves many small tasks occurring at the same time or in parallel. This type of parallel computing is very specific and does not suit all types of processor. The CPU, or central processing unit, is typically seen as the brain of a computer, and it's very adept at doing tasks very quickly and often at the same time. However, it does reach a limit as to how many concurrent or parallel tasks can be achieved without bottlenecks forming. In contrast, a GPU, or graphics processing unit, is designed for the rendering of high-resolution images and video concurrently, both hugely parallel workloads. Because GPUs have thousands of cores, they can perform parallel operations on multiple sets of data, so they're also perfect for non-graphical tasks such as scientific computation, machine learning, and deep learning. Adding one or more GPUs to a system is termed GPU-accelerated computing, due to the fact that intensive parallel workloads are offloaded from the CPU and moved to the GPU for better performance. Just how much additional performance is dependent on the cores within the GPU and the amount of dedicated memory it's got. It also depends on how many GPUs are used together. When GPUs are grouped together in this way, they're capable of delivering even more parallel processing power. This is done by two technologies from Nvidia called NVLink and NVSwitch. Nvidia NVLink is a high-speed direct GPU to GPU interconnect, whilst Nvidia NVSwitch takes interconnectivity to the next level by incorporating multiple NVLinks to provide all-to-all GPU communication at full NVLink speed. NVSwitch is the first embedded switch architecture to support up to 16 fully connected GPUs in a single server node. These 16 GPUs can then be used as a single high-performance accelerator with unified memory space to deliver a vast resource of deep learning compute power. So now we understand how GPUs provide the power to make deep learning possible, but how's it actually done? Scientific computing, whether machine learning or deep learning, is carried out by using a programming language. To avoid learning an entire language, frameworks or libraries are employed to automate and structure some of the tasks. Frameworks are pre-compiled collections of pre-scripted libraries and models, and they provide the easiest way to start a deep learning project. Libraries can be used standalone if more controls required, but more coding experience will be required. Whether you use a single or multiple Nvidia GPU, these frameworks and libraries can be downloaded from the Nvidia GPU Cloud, abbreviated to NGC. This is a free repository of dedicated deep learning and high-performance computing resource, all optimized for Nvidia GPU accelerators. So now we've covered what makes deep learning work, why not watch the next video in this series, the 4 stages of deep learning.